In this video, let's talk about Bayesian optimization with Python. So I'll be referring to Medium articles. Firstly, why do we use Bayesian optimization? And I'll add the link of both the articles in my description of this video. So why do we use Bayesian optimization? What is Bayesian optimization? So basically, whenever you want to fine tune your hyperparameters, what is hyperparameters? Some inputs that are machine learning model takes is uh, is basically fine tuned or is basically selected by our optimizer, which is Bayesian optimization. Okay, so Bayesian optimization is this thing which will try to select input for our machine learning model so that we can get the best result. In layman's term, what Bayesian optimization is basically, it will try to select an input for a machine learning function. So for example, in SVC, we need to give C as an input. In random forest, we need to give number of trees as an input. And what Bayesian function will do is it will try to give you an best input value so that your model will be much more accurate. And how it works is basically what we try to do is we have an input and it gives you an output. So Bayesian optimization tries to give you a local minima. Okay, for a cost function, what Bayesian optimization tries to do is it tries to find a local minima, and it will use all types of input, and the input which gives you the local minima will be your hyperparameter. So this is what Bayesian optimization is. It basically will be helpful for selecting an hyperparameter, selecting a hyperparameter for you. And let's refer this article. What it tries to do is I'll explain you with this code. We are importing view libraries. There is cancer dataset in sklearn, which we are using, and we have defined our X and Y. We are splitting it. We have scaled using min-max scaler, and after scaling it, I'll define my black box function, which is my model. And in this case, I'm using SVC. I'm using SVC, and C is my hyperparameter. Okay, C is my hyperparameter. That is an input to this function. Now, I'll use Bayesian optimization, and what it will try to do is it will try to give me best possible C. So if you see here, I'm trying to give a range. Give me a C between 0.1 to 10 so that I can get best output, which is most accurate output and the minima, local minima for my cost function. Okay. So it is as simple as you import Bayesian optimizer and you just give your function, your black box function. That's it. After that, you will be giving your bounds between which it will be searching the input, and that's it. So if you see, this is what it looks like. It went for 15 iterations. It was selecting C values. If you see, it was selecting C values, and what it did was best result for your 8.5. For this C value, you are getting best result, and this is your Y. This is your Y, which is 0.998. So if I see 8.5, 8.505, the output which I'm getting is 9981, which is highest, 9981. Okay, so this is how it works. Now let's go into the conceptual level. Let's see how it works at a conceptual level. So this is a range of our hyperparameter, basically our P bounds. Okay, so this is the range, and what we try to do is it will try to select a hyperparameter and the objective function, which is our black model. It will try to give a minimum value for our cost function. In this case, the cost function is your RMSE score. Are you getting it? What we try to do is, we try to select a hyperparameter and we plot it against RMSE score. But in this case, we won't be doing manually. nor we will be going through each and every possible input in that bound. We will be using Bayesian optimization. We will be using Bayesian optimization. So now the question is, how do we, or how does that Bayesian optimizer selects the hyperparameter? So there is something called as acquisition function. There is something called as acquisition function. And what it tries to do is, uh, basically it will select an hyperparameter, and so what this function does is, it this is the thing which tries to select a particular point. Okay, so rather than going through each point, it will directly select a point, and that's how Bayesian optimization works. You can see this uh, acquisition function. So we need to build an acquisition function, also called as selection function. The next hyperparameter of choice is where the acquisition function is maximized. So acquisition function will give me an idea on which hyperparameter to select next. So this is what hyperparameter function does. Sorry, acquisition function does. And if you see this in this particular photo, in this sample which we have, basically p bound, the maximum value of acquisition function is at this point, and so this is the new thing added. This is the new thing added. So what Bayesian optimization does is, basically it tries to create an uh, basically it tries to project what will be your output of your cost function for your hyperparameter, and this is the algorithm for it. This is an uh, algorithm which is basically, SMBO is your sequential model based optimization. SMBO is your sequential model based optimization, and it is as simple as, for each like in each iteration, what you try to do is, you calculate your cost function and then you update your hyperparameters, and this type is what your Bayesian optimization does. So few things to remember: we have H, which is your observation history; T, which is total number of iteration, like total number of iteration you want to. F is your objective function or cost function, which is RMSE in this example. S is your acquisition function, which is basically, it tries to tells you which hyperparameter to select next. And there is this is the most common acquisition function which is used. This is the most common acquisition function which is there, which is usually used. And basically, just to sum up what we have seen today is, if we have uh, a list of hyperparameters, what we try to do is, uh, first, what we can do is, we can select each hyperparameter manually. Like for this, I can select this. For second list, I can select this, and third list, I can select this. So I can manually select and compare the results. Third, second option which I have is basically to go through each hyperparameter one by one and see the combination which gives me the best output, or in our case, the local minima. So it will give me a best combination of this and this hyperparameter, which gives me a best uh, uh, output. Third thing which we can do is, there is something called as random search, which will randomly search, and uh, will give you an output. So on basis of this output, you will select. Okay, but this is more random. Like this is completely it doesn't has any logic. It is a random thing. So the fourth option which we have is Bayesian optimization, which will basically predict which sample to use, rather than going through each sample or randomly selecting sample, or manually selecting sample. It will suggest you which, like which sample should be chosen next. in the list of this hyperparameter and basically give you the output. So this is how it works. In next video, let's see how we try to see the math. Like let's try to see the math of this Bayesian optimization, how it works. Currently, this is like I went to a conference where this thing was discussed, and uh, I thought of creating a video. I'll try to study it. I'll try to study the math behind it and try to come up with new video. So that's all for this video, I think. Thanks.